First today, let's do a little review of complex numbers. Now, I can find a good pen. Complex numbers are basically all numbers. So if we are talking about complex numbers, they are numbers of the form z is equal to a plus bi. A is the real part and b is the imaginary part. So we can break complex numbers down into real numbers. That's when b equals 0. For example, 5 plus 0i, 6 plus 0i, 9.2 plus 0i. Of course, we usually don't write the 0i part. When we're talking about imaginary numbers, the b part does not equal 0. So 2 plus 2i, 7 plus 6i, 9 minus 3i, 0 plus 2i. These are all imaginary numbers. Of course, 0 plus 2i would be just written as 2i. If we're going to graph complex numbers, we want to set the x-axis or horizontal axis up as the real axis, and the vertical axis or the y-axis will now be the imaginary axis. So if I asked you to graph z is equal to 3 plus 2i, that would be over 3 and up 2. And there would be our point, 3 plus 2i. Notice there is our point, 3 plus 2i. That means we're going to go over 3 in the real and up 2 in the imaginary. So our magnitude or our absolute value of this complex number is the distance from 0. We're simply going to use the Pythagorean theorem. So if we take the general case, z is equal to a plus bi. Now that is standard form of a complex number, a plus bi. Clearly, the distance from 0 here will be, if we use the Pythagorean theorem, a squared plus b squared. Notice I'm not including the I in this. So for this example, this would be 3 squared plus 2 squared, which would be 9 plus 4 is the square root of 13. If we're talking about this complex number, z is equal to a plus bi, and I put this here in the second quadrant. Well, if I want to get there using standard form, I'm going to go over a and up b. If I want to think about this in terms of trig form, well, I'll need to know what is this angle and what is this distance. We just called this the absolute value of z, and now we're going to call it r. It is the same, mechanically, it's going to be found the same way that we found the absolute value of z. So the absolute value of z is r, and r, some vocabulary, is known as MO, the modulus, and this angle here is known as the argument. So if we do a little trig here, remember this is theta, this will be theta prime. We take our eyeballs and look through theta prime to find our trig ratios. Here we have SOHCAHTOA because this is a right triangle. So cosine of the angle will be A, adjacent over hypotenuse, and sine of the angle will be B, opposite over hypotenuse. If we do a little math manipulation, multiply both sides by r, we get A is equal to r cosine theta. If we multiply both sides of this equation by r, we get B is equal to r sine theta. So if I'm talking about the standard form of a complex number, a plus bi, now I can make my substitutions. Z is equal to, well, a is r cosine of theta, and b is r sine of theta. If I clean this up a little bit, I get z is equal to, factor out your r's, r, and I'm left with cosine theta plus, usually pull this I to the front, I sine theta. And this here, if this was standard form, this is what we call trig form or polar form, or sometimes you hear it called R-cis form. Knowing we have both trig form and standard form, this is a typical question we might see. Write z, now this is in a plus bi form, and we're asked to put it into trig form. So the first step I would take would be to graph it. Here's our real number system, and here's imaginary. negative 6 plus 5 is going to put us here in the third quadrant. So we need to know what is this theta and what is r. Now r is fairly simple. It's going to be real squared plus imaginary squared. Negative 6 squared plus 5 squared. And then we're going to take the square root of that. So the modulus will be, when all is said and done, the square root of 61. If we're given opposite and adjacent, that smacks of tangent to me. Tangent of this angle is 5 over negative 6. So our angle, if we take inverse tangent of negative 5 over 6, we're going to get a negative 39.8 degrees. Now we've got to use our head. The calculator just told us negative 39.8 degrees. It's giving us this fourth quadrant angle because of the restrictions on inverse tangent. It's only going to yield an angle between either in quadrant 1 or quadrant 4. And so it gave us this quadrant 4 angle. We've got to use our heads and add 180 degrees to this to be able to come up with the angle as 140.2 degrees. So now that we want to write it as z equals r times cosine theta plus I sine theta, that's our goal. We can say z is equal to the square root of 61 times cosine of 140.2 degrees plus I sine of that same angle, 140.2 degrees. Sorry, that's a little cramped there. But that's the way we're going to go about this. Another problem might be like this. Now we're given polar form or trig form or R-sys form. They say, what is standard form? So we have to understand our goal is to write this as z equals a plus bi. So I would also draw a little sketch. Here is our angle, 2 pi over 3, and the distance here is 8. Well, if this were a unit circle, I would say our reference angle is pi over 3, forcing this to be root 3 over 2, and this as negative 1/2. So the cosine of this would be negative 1/2. So we have 8 times negative 1/2 plus, this would be root 3 over 2i. The key to going from trig form to standard form is simply to distribute your modulus. So z would equal negative 8 over 2 plus 8 root 3 over 2i, which would simplify to negative 4 plus 4 root 3i. And there is our complex number in standard form. Hope you enjoyed today's lesson.